So today we have a very interesting and beautiful geometrical problem. The question says that four circles of same radius are tangent to each other and also to the sides of the triangle. If in the triangle ABC the sides are 13, 14 and 15, then what can you say about the radius of the circle? Okay, so now let us proceed to the solution. So the first thing is that one of the theorem that we are going to use, and we still don't know the name, but let us use, and it is two circles tangent theorem. Let us just make the font bold. Yes, I just call it two circles tangent theorem. Now what does this theorem state is that if there is a circle and there is another circle that is tangent to it either externally, or the two circles are tangent to each other internally, in both the cases the center of the two circles and the tangent point will lie in a straight line. The center of the first circle, the center of the second circle and the tangent point, this all the 3 points would always be collinear. Okay, so this data we are going to use in this particular question. The second thing that we are going to simply use is that tangents drawn to a circle from same point are of equal length. These are all school theorems that we all know. Tangents drawn to circle from the same point are equal. This simply means that if there is a circle, if you choose a point P, from the point P if you draw a tangent, and from the same point P if you draw another tangent to the circle, the length of the tangent between the point of the contact and the point P would be equal. This length would be equals to this length. Okay, so these are the few theorems that we are going to use. Furthermore, in the same theorem we can conclude this also, that the radius of the circle, sorry, the radius of the circle, yes, obviously the radius of the circle is tangent, the radius of the circle is perpendicular to the tangent at the point of the contact. So these are the theorems that we are going to apply in our question. So first thing, let us apply the radius is perpendicular to the tangent theorem. So if I just take this as the centers of these particular circles first of all, so what I can say is for this circle this would be the radius and hence it meet at 90 degrees. Similarly this would be the radius and it will meet at 90 degrees. All the radius drawn to the tangent sides of the triangle would meet at 90 degree. Okay, nice. Now also we have to find the radius of the circle, so we'll start the solution as let the radius of the circle, let the radius of the circle be x. So all this length can be marked simply as x. Nice. Okay, now look carefully. If I consider each of these angles, the angle A as equals to alpha, the angle B as equals to beta, and the angle C as equals to theta, what will happen when I draw this kind of dotted lines? And before that, let us also conclude some beautiful fact over here. So what I will do is I simply join the centers of this adjacent circles, not with the main middle circle, but with the adjacent circles. Now look carefully what has happened. Can you see this particular figure over here? These particular figures that have formed on all the three sides, what can you say about them? Are they rectangles or are they parallelogram or are they simple quadrilaterals? The answer comes out to be that they are perfect rectangles. Why? Because opposite sides are not only equal because they are the radius of the same circle, so they are equal, and also they are perpendicular to the same base. So just imagine you have a base, then you have perpendicular lines on it, and what you have done is we have cut the perpendicular lines of the same length. So simply it also, these are two pillars of the same height, so if you join the head, what will form is a beautiful rectangle. So if it was just 90 degree and height was not same, then it would form a trapezium because these two sides are definitely parallel. Or we can use this well-known fact that if opposite sides are parallel and opposite sides are equal, it forms a parallelogram, and if the angle is 90 degree, it will form a rectangle. So basically we have seen that these four figures over here are beautiful rectangles. Now if they are rectangles, the first thing is that opposite sides would be equal. So the x is already equals to x. The other thing would become that this side is equals to this side. Similarly we will have that this side, wait, the thickness is very small. Yes, the second thing we will have that this side is equals to this side, and the third fact that we will have, let us change, let us use the green color. Yes, the third fact we will have is this side equals to this side. Okay, now apart from the opposite sides equal, the rectangle also gives us a fact that all the four angles are 90 degree. So two of the angles were already 90. So now look carefully, I'll just remove the x for now. So now look carefully, this angle will come out to be 90, and similarly this angle would come out to be 90 degree. Now look over here in this particular figure. It is a four-sided figure. Three of its angle are well known. Beta, one angle is beta, the other is 90 and 90. By angle sum property, we can conclude that the third angle will turn out to be 180 minus beta. Now over here, we can apply the complete angle theorem that around a point, the sum of all the four angles should be 360 degree. And doing so, we will have that this angle is equals to beta. So we can see that the inner angle and the outward angle are same. The same fact can be concluded at all these three vertex. So this will come out to be theta and this will come out to be alpha. The top angle will get replicate over here. Nice. Okay. Now let us do one more thing. The second theorem that we have seen over here, not the second, the first theorem, that the tangent point, the center of the two circles would be collinear. So what will happen if I draw in these lines? Now let the thickness be less, it would be helpful. So if I draw a line from here to here, you can see the center of the two circles are connected and also the tangent point is connected. So it is a perfect straight line. Now the length from here to here is the radius of this circle, that is x. The length from here to here is the radius of this circle, that is again equals to x. So the overall length would come out to be 2x. So this line is having a length 2x. The same thing will happen on this particular side. This length would be equals to 2x and the same length would be over here, 2x. So all these three lengths are 2x and let this center point be equals to O. Okay. Now again look carefully. Can you see this triangle that has formed inside? So we have some figure like this way. A triangle is in the middle and then we have the center, and from that center we have three distinct lines and all of them are having the same length, that is 2x, 2x, 2x. Now from this you can simply conclude a very nice fact that this might be the center of the circumcircle of this triangle. Means you can draw a circle around this figure using this as a center and radius is equals to 2x. Okay. Now as this particular point is the center, let me introduce you to the third theorem that we are going to use. The third theorem, wait, the eraser is not working. Yes. Now the third theorem that we are going to use is states that angle subtended by chord at center, angle subtended by chord at the center is double the angle subtended by chord at circumference. Okay. Now what does this mean is that inside a circle, if you choose a chord, and from that chord, if that chord is subtending some angle at the center and some angle at the circumference, the relation is that if the circumference angle is A, then the center angle would be 2A. Okay. So this is also a very well-known theorem and it's basically taught in school also. So now look over here. We already have this angle as equals to beta. Look in the main diagram I am showing over there. So that angle is beta, so this angle would be beta. So if this chord is subtending an angle beta at the circumference, this means that it is going to subtend an angle 2 beta at the center. Okay. So what I can see is that this angle is equals to 2 beta. Now look carefully, we have this 2 beta, very nice, but these two sides are equal. So hence these two angles would be equal. So by angle sum property, I will have a fact that this angle is nothing but 90 minus beta. Nice. It has come out to be 90 minus beta. Till now some things are going good. Keep all this fact. Now let us introduce one more thing. The theorem that tangents from the same point are equal. So from the point B, we have the tangents length over here and here. So they would be equal. So let the length given B and B, the top length be A, and this length be C and C. Okay. Now look carefully. This length is equals to A, this length is equals to C. So the remaining length would be 14 minus A minus C, and that would be this red length that I have marked when I was explaining about the rectangle. So ultimately this length is equals to this length, hence this length would turn out to be 14 minus A minus C. So in this diagram also let me mark this, this side would turn out to be 14 minus A minus C. Okay. So here we have a very nice triangle with the two sides as 2x and 2x, one of the side as 14 minus A minus C, and one of the angle as 2 beta, and two of the angle as 90 minus beta. That's very important. Keep that thing as it is. Now coming back to our main diagram, we can see that I have this vertex angle as alpha, beta and theta, and also the triangle sides are completed. Let me just draw this again. So I have this very nice thing that the top angle is alpha, this angle is equals to beta, and this angle I have taken as theta, and also I have these sides 13, 14 and 15. This means that from the perspective of all these three angles using the cosine rule, let me introduce that also. cosine rule. The regular viewers would get bored because they all know the cosine rule, but still, if the three angles are ABC and this angle is theta, then the value of cos theta according to the cosine rule is simply a square plus b square minus the c square upon 2ab. The adjacents are important, minus the opposite side, squared all of these values and divided by the 2 times the product of adjacent side. Okay, so using this cosine rule I can actually have the value of cos beta, cos alpha and cos theta. So let us do that very quickly, and I'm not going to show these steps because that will make the video lengthy. Let me just directly write it down. So starting from cos alpha, so the value of cos alpha would turn out to be 13 square plus 14 square minus 15 square divided by 2 times 13 times 14, and this value, wait a minute, let me see my rough work. Let me see my rough work. This value would turn out to be 5 by 13. Okay, now the value of cos beta, the side angle, would turn out to be 33 upon 65 in the similar pattern, and the value of finally the cos theta will turn out to be 3 upon 5. Nice. Okay, now again moving to our diagram, what happens if I draw a line from here to here? We all know that these two triangles will become congruent to each other by right angle hypotenuse side, and hence these two angles will become equal. Now each of this angle, the complete angle is already equals to what? It is equals to beta. So each of this individual angle will divide and turn out to be beta by 2 and beta by 2. The half of the angle beta. The complete beta will get divided. Now look carefully. We already have the value of cos beta, cos theta and cos alpha. There is no need to find cos beta by 2, that's not required. Over here, look carefully. The theta will get divided as theta by 2 and theta by 2, and similarly the alpha will get divided as alpha by 2 and alpha by 2. This angle would be alpha by 2 and similarly alpha by 2. Now why I am saying that we don't need, in fact why are we finding this half angles, is because the variable x is very important because that is the radius of the circle, but these variables a, b, c are not important as we have put from our side, and the best way to proceed in any solution is to reduce the variables. So what I'm trying to do is reduce ABC in terms of x, or either we can find its value. That's not possible. Let us reduce the values of A, B and C. So look carefully in any of this triangle. For example, I take this particular triangle over here. In this triangle we can see that we have the angle theta by 2. So from that perspective, if I try to find the value of tan theta by 2, what will happen is opposite side is x and the base is c. And similarly from this alpha perspective, the value of tan alpha by 2 can be found out, and it will turn out to be what? Tan alpha by 2 will turn out to be x upon a. Yes, x upon a. So what we actually need is the value of tan theta by 2 and tan alpha by 2, and once we have that, we can find the value of x upon c and x upon a, means we can equate it with that. So what we have is theta and alpha. So look carefully over here. The value of cos alpha is already 5 upon 13. So what can you say about cos alpha by 2? So we know this theorem that cos alpha is simply 2 times cos square alpha by 2 minus 1. So cos alpha is 5 by 13. So we'll have 5 by 13 plus 1, that will turn out to be 18 by 13, divided by 2 will give us 9 by 13, and the square root will result in 3 upon square root of 13. This is the value of cos alpha by 2. Means we have a right angle triangle like this way. This angle is equals to alpha by 2. The base is 3. The hypotenuse is square root of 13. So 9 and 13 minus 9 means the height is equals to 2. So the value of tan alpha by 2 will turn out to be 2 by 3. So this can be compared with 2 by 3. So 2 by 3 is equals to x upon a. So the value of x turned out to be 3x by 2. Nice. Now moving back over here. Now what we need is theta by 2. Okay. So we already have the value of cos theta. So cos theta is 2 times cos square theta by 2 minus 1. So 3 by 5 plus 1 will result in 8 by 5. Division with 2 will give me 4 by 5. The square root will give me 2 upon square root of 5. This is the value of cos theta by 2. Means we have a right angle triangle containing an angle theta by 2. The base is 2, the hypotenuse is root 5, means the height will turn out to be 1. Hence the value of tan theta by 2 is 1 by 2. So 1 by 2 is equals to x by c, and therefore the value of c will turn out to be 2x. Nice. Okay. Now look carefully, the value of a and c were required in this side as it was 14 minus a minus c. So now what we can write is that this value is simply 14 minus 3x upon 2 minus 2x. So it will make it look like 14 minus 7x upon 2. keep that thing as it is. Okay, now look carefully in this particular triangle. In this particular triangle, we can have the value of cos beta sine beta, means from this perspective or else this perspective we can find the value of, we can use the cosine rule to find some kind of value and proceed in our solution. So finding from this side is makes two chaos. The first thing is that no silence will get cancelled out, and the second thing is that we have to deal with cos 2 beta. So what I prefer is to use this one. So from this perspective, if I find, so cos 90 minus beta would be equals to 2x the whole square minus 14 minus 7x by 2 the whole square, sorry, plus then minus 2x the whole square. See, adjacents are this one and this is the opposite. So the two things are happening nice over here. First of all, we have to deal with a single beta angle, and the other thing is that these two sides are going to get cancelled out, and in the division we'll have 2 times 2x times 14 minus 7x by 2. So finally, now cos 90 minus beta is also famous. It simply turned out to be sine beta. So sine beta has a value. Now look carefully, this also the square will get cancelled out with this one. 14 minus 7x upon 2 divided by 2 into 2, 4x. So finally this thing is, or we can just conclude this thing very nicely, that we have the value of sine beta as equals to 28 minus 7x upon 8x. This is the very nice value of sine beta. Okay, now do we have a numerical value of sine beta? So definitely yes. Look carefully, we utilized cos theta to find tan theta by 2, and we utilized cos alpha to find tan alpha by 2, but we didn't utilize cos theta. That was the ridiculous value of all of them, that was 33 by 65. So now we'll utilize cos beta to find sine beta. So look carefully, it's 33 by 65. So cos beta, we have, we can say that we have cos beta is equals to 33 by 65. So what can you say about sine beta? So sine beta will simply turn out to be the square root of 1 minus cos square beta, means 33 square upon 65 square. So in the denominator we'll have 65, in the numerator we'll have the square root. 65 square minus 35 means a square minus b square. So a minus b will give us 32, and a plus b will give us 96. Okay, now it's simple that 96 is what, is it 33 in 32 into 3? Yes, yes, no, wait, am I doing something mistake? No, it's correct. So 96 is 32 into 3. 326 and 339. So we have 32, 32 and 3. So it simply turn out to be 32 square root of 3 divided by 65. This is the value of sine beta. Is this something wrong because we are having a square root? That's not suiting. Wait. It's 9. Oh, wait, it's not 96. Yes, the mistake I got over here. I thought that previously we made a mistake. So, no, over here, 65 minus 33. It's means a square. Wait. In the denominator, we'll have 65. In the numerator, we'll have 65 square minus 33. That's 32. Square root में 32. And then adding will give us 98. Okay. So now 98 is basically from the table of 2. It's 49. So 2 into 7 into 7, and 32, it's basically 2 5 times. So overall we have 2 to the power 6 and 7 square. So we'll have 2 to the power 3 into 7 upon 65, means 8 into 7, that's 56 upon 65. Okay, so 56 upon 65 is the value of sine beta. Nice. So as I told you, do we have a numerical value of sine beta? So answer come out to be yes, 56 upon 65. So now finally, out of all of this, I first of all, sorry, I just go randomly here and there writing the solutions. I'll try to improve. If you guys comment, you nobody comments that sad thing, but if you guys comment that how and where, if you like this, then whatever, give suggestions. Okay, so finally sine beta means 56 upon 65. This thing would be equals to 28 minus 7x, and in the division we'll have 8x. Doing the cross multiplications, so 8 6 48 and 480 48. So it's simply going to be 448x, and that's equals to 65 into 28 minus 75 35 245x. Adding 245 over this side, so 245 will get added. So we'll have x and 319 693x is equals to 65 into 28. So finally the value of x will turn out to be 65 into 28 upon 693. Do we have some table that will cancel it out? So from the table of 2, can we cancel out something? 65 and 28. 65, 28, none of this comes in the table of 3. Or else 120, 1, anything that comes from the table of 13, can we cancel out anything? 7, no, not the table of 7. Let us see, 56 upon 65 is 28 minus 7x upon 8x. 56 into 8, 8 6 48, 8 5 40, 448. Nice. 7 5 35. Oh yes, it's 7 into 6. So 7 into 6 is not 243. Wait. I got my mistake. So yes. So 7 5 35 and 7 6. So it's 420, not 4 again. Wait. We have to add the 3, so it's 455. 455x. So 455 will get add. So we'll have 3 and 1 carry, 0 and 1, 903 in the denominator, 903. Now let us see, can we cancel out some things? 903, 1 from the table of 7, I guess. From the table of 7 it's 4, from the table of 7 it's 1, then 20 and 9. Now nothing will get cancelled out. Yes. So finally x, 65 into 4 means that the one double of 130, that's 260, and in the division we will have 129 centimeters. Why centimeter? Because the sides were already in the centimeter. So this is the value of the radius of the circle. Now all of this means, what it was the main thing that we used was the sides were given pretty nice, 13, 14 and 15. If they were random, a, b and c, you can just imagine how chaotic, or would it be very simple, as in the last video, last to last, it means one of the previous video, we got that beautiful relation. I have posted that in the community post, you can see that. So if the sides were a, b, c and random, so first of all we would have these values of cos theta, cos alpha in the terms of that sides x, y, z variables, and so would be the value of tan theta by 2, means yes, it would be very chaotic. I guess, I am not sure, I am just 50% sure that if to generalize this particular problem, the sides of the triangle needs to be very nice, and if someone tries to just keep it x, y, z and do it, very nice approach will get, means you will get a particular answer, but I think that it would be very chaotic, means square roots and square root squares. Let's see in the audience if anyone's try. I am pretty lazy to try it right now because I have lots of work to do. But yes, if someone motivates, I'll do that for sure. Okay. So this was my way to solve this particular problem. If you have any other method other than this, you can do comment below. And if it's a photo or a PDF that you want to share of the solution, you can email me. The email address is in the description. And guys, do like and subscribe the channel. It will help to the channel to grow, and also it will keep me motivated to bring this kind of beautiful geometrical problems to all of the audience. You also know that nobody on the YouTube community does this kind of geometrical problems. Yes, the voice, the video quality is not that good, but yes, I promise the content that you will get over here is nice. And also I have not got any formal training in solving these problems. It's all the lockdown I have spent thinking and solving, so that's what I have. So sometimes the method can be lengthy, long, or boring, but because I don't know any shortcut tricks or any these kind of things, it's all the natural things that I have from my side, because it's all homemade. Okay, so that's what I can say. But yes, if you guys are having a proper training and all the kind of stuff, and if you got any kind of sort of solution, be uh, polite to share in the comment, and also you can email me and I can also learn from that and mention that in the community post. Okay, thanks for watching, and again I am reminding, do subscribe to the channel and like this video. Okay, see you. Bye bye.